Hi, hello, how are you? Good evening, everybody. Welcome to India's number one online platform, Gradeup. So, the topic of today would be multi-level paging. Basically, main topic of today would be multi-level paging, which is really very important for any examination, whether you talk about GATE or you talk about any PSU examination. So basically many students are confused about multi-level paging. So that is the reason I have kept this name as the topic name. So quickly like the session and share the channel and subscribe and click on the bell icon. This is all about me. My name is Navneet Gupta and I have 8 years of teaching experience and I got 92nd rank in GATE 2008. Okay, and I am UGC net qualified. So many things here I have written. You can just read it out. And today is the last day of the year. Okay, and from tomorrow onwards, we will be having a new year. So on the occasion of new year, basically new year virtual party. Okay, so uh, I have kept here it. So it would be on 1st January 2021 7 p.m. right, with the हम होंगे कामयाब with Gradeup. So you please be connected with Gradeup and 100% you would be कामयाब. Correct. So please take a resolution on 1st December, that is tomorrow, कि you have to get successful in this coming year 2021. Now we'll start the session and here is the question number 1 which I wanted to ask you. So before multi-level, whatever I have taught you, I will ask you some questions. So what would be the answer of this question number 1? Tell me. So here in this question, if a page number is not found in the TLB, then it is known as dash TLB miss, buffer miss, TLB hit, all of the mentioned. I told you कि CPU will generate the address and we will find it in TLB. Okay, and if it is in TLB, then we call it as TLB hit. But if we don't find it in the TLB, then we call it as TLB miss. Right? So the answer of this question number will be option number A, TLB miss. Here is the question number 2. Tell me the answer of this question number 2. So in this question number 2, and dash uniquely identifies processes and is used to provide address space protection for that process. Address space locator, address space identifier, address process identifier, or none of the above. So the answer of this question number 2 will be option number B, address space identifier. Basically this is uniquely identifies the address space of each process. so that you can protect your address, your processes. Here is the question number 3. What would be the answer of this question number 3rd? The percentage of times a page number is found in the TLB is known as. So the percentage of times a page number is found in TLB. So I told you page number can be found in TLB. So we call this as miss ratio, hit ratio, miss percent, and none of the above. So we call it as hit ratio. So the answer of this question number 3rd will be hit ratio. Question number 4. So in this question number 4, memory protection in a paged environment is accomplished by dash. So memory protection, we are talking about memory protection in a paged environment, means paging. We are using basically paging. So this can be achieved with the help of which one? Option A, protection algorithm with each page, restricted access right to users, restriction on page visibility, protection between each page. So the answer of this question will be option number D. So basically protection bits are used for memory protection. As you know, we have a page table, and with the page table we can have like frame number. So this is about entry of the page table. So frame number normally we keep. Now here we can keep like dirty bit, invalid bit, and many more bits we can have in this, like protection bits. Correct. So the whole, this complete becomes a entry of the page table, right? That is known as E. Normally it is in byte. So protection bit are used for memory protection in paging. Here is the question number 5. What would be the answer of this question number 5? So the question is, when the valid and invalid bit is set to valid, okay, it means that the associated page is in the TLB, okay, or it has data in it, it is in the process logical address space, or you can say it is the system physical address space. So basically valid invalid bit is used for telling you that the page, for example, it is valid, it is valid, it is invalid. For example, this is 0 page, 1 page, and 2 page. Now here valid means basically we have 0 and 1 page in the memory, in the basically RAM. And now if it is invalid, the meaning of this will be the page exists. ऐसा नहीं है page doesn't exist, page exists, but page is in the hard disk, right? So valid means the associated page is in process address space, right? So the answer of this question will be option number C, right? Now the next question would be, so before moving to the next question, I would like to tell you about Gradeup Vision 2022 batch. So it is a batch number 3rd which we have launched, and here we will teach you 550 hours of live classes and 5000 plus practice questions in the test, 100 plus mock test, 100 plus chapter wise study notes we will provide you, right? And this is ideal for second year and third year engineering student. For more information you can contact on this number. And in all the batches, whether we talk about Vision 2022 or Rank Up or Gear Up batch, so here is the faculty list. Like Murli sir, Satya sir, Ankit sir, and myself will be teaching you our respective subject. Okay, so you should join our paid batch. Now we will be moving to the question number 6. Here the question number 6 says illegal addresses are trapped using the dash bit. What would be the answer of this question number 6? Illegal addresses means suppose we are entering some address and that is not within the range of the process. So we call this as the illegal address. And now we can find this illegal address with the help of error or production or invalid valid bit or access. So here the answer of this question number 6 would be option number C, valid invalid. Okay, bit. Illegal addresses are trapped using the valid invalid bits. Correct. If you have any doubt, please let me know. Okay, so here we will go ahead with the question number 7. Tell me the answer of this question number 7. When there is a large logical address space, the best way of paging would be. So here the answer of this question number 7 would be, so when we have a large logical address space, we have a huge LAS, right? Then the best way of paging would be a two-level paging algorithm, right? We can have two-level, three-level. Here is the question number 8. Tell me the answer of this question number 8. In a paged memory, means in paging, the page hit ratio is 0.35, that is 35%. The time required to access a page in the secondary memory is equal to 100 nanosecond. The time required to access a page in primary memory is 10 nanosecond. The average time required to access a page is, okay. So 0.35 multiplied by, tell me the answer, what would be the answer of this question number 8? So if we get the page basically, so it will be 0.35, and what is the access time in primary memory? 10 nanosecond. But if we don't get, so it will be 1 minus 0.35, and we have to check in the secondary memory. Okay, and in the secondary memory it is 100 nanosecond. Now if you multiply 0.35 into 10, and so you will get 3.5 plus 1 minus 0.35, 0.65 multiplied by 100. So you will get 65. So if you add them, it will be 68.5 nanosecond. So the answer of this question will be option number C. I hope now you understood. Correct? Here is the next question number 9. Tell me the answer of this question number 9. To obtain better memory utilization, dynamic loading is used. Right. With dynamic loading, a routine is not loaded until it is called. For implementing dynamic loading, special support from hardware is required. Special support from operating system is required. Special support from both hardware's operating system required. Or you can say user programs can implement dynamic loading without any special support from hardware or operating system. So if you see, dynamic loading is the way whenever you need the process or you need some pages, then it will be loaded whenever it is needed. So there is no special support from hardware or operating system, right? So the answer of this question number 9 will be option number D. Correct? Okay, now we will go ahead with the topic, multi-level paging. So what do you understand by multi-level paging? So basically multi-level paging is a you can say it is a way or it is a scheme to have multiple page table, right? This is known as multi-level paging. So multi-level paging, I will write one line. Multi-level paging is a paging scheme where there exists a hierarchy of page table. So we have multiple, or we can say we have many page tables, right? So multi-level paging is a paging scheme where there is a hierarchy of page table, like one page table, two page table, three page table. This is called as multi-level paging. What is the need of multi-level paging? So the need of multi-level paging is here. Suppose the page table size is so huge, it cannot fit in the frame, right? For example, your frame size is 4 KB and your page table is 128 KB. So definitely your page table cannot fit into the frame. So what you have to do, you have to divide your page table into one 4 KB 4 KB 4 KB pages. Okay, and for storing the same you can say pages of page table, again you need one more page table. So the size of the page table is so huge, that is one reason. And as a result, the page table cannot be stored in a single frame in main memory, right? So you have to divide this page table into multiple pages, and now we call this as the multi-level paging. Correct? So now you please copy all these 2 points, then we will take up one example, then it will be better understandable. If you have any doubt, you can ask me. Yes, Hitesh, I remember. So, are you a student of Jhansi? So, where you are giving your examination, gate examination? Okay. So, Hitesh, you give your email ID and I will communicate to you. You can write, you can type your email ID here, and I will definitely try to talk to you. So, here we will go ahead. So if we take the example of multi-level paging, before taking the example of multi-level paging, I will tell you about Gradeup 2020 achievement. So in GATE 2020, we have 4th ranker, we have 20 ranker, we have 39 ranker, or you can say 60 plus Gradeup student have got a top 100 ranks. Okay, in computer science, I am talking about. So you can also get a good rank if you join a Gradeup. And very nominal fee we have, very less fee we have. For 3 months we have only 9,000 rupees. For 12 months it is just only 22,000 rupees. For 18 months 30,000, or for 24 months 36,000. For more information you can contact on this number, or you can send email on this email ID. This is under Gradeup Super, and you can access many live courses if you purchase under Gradeup Super. Not only one course, you can access many courses. Right? Okay. Now here we will go ahead. Ha Hitesh, I remember. That is the reason I said to you for email ID. I remember you. So what's going on? Okay. So now please try to understand the concept of multi-level paging. Consider a system using paging scheme where logical address space is 4 GB and physical address space is 16 TB and page size is 4 KB. So basically, suppose now this is your logical address. I told you कि logical address space is equal to 2 की power logical address, and they are saying logical address space is 4 GB is equal to 2 की power LA, right? 4 means you can write 2 की power 2, and G means 2 की power 30 is equal to 2 की power LA. So basically LA, if you try to find LA, will be 32. So the complete logical address will be 32, and it is divided into P and D, as you know. So P and D. Now, as you know, size page size is 4 KB, 4 KB, and you know formula 2 की power D is equal to 4 KB. So you can write 4k as 2 की power 2 4 and k means 2 की power 10. So 4kb will be 12, यानी कि d will be 12, and if you subtract 32 minus 12 it will be 20. So now I have to find the page table size. If you try to find page table size, the formula is n into e. Now they have not given the e, but they have given the physical address space. So with the help of this we can find it out e. So basically if you see this 16 TB is the PS. So physical address will be 16 is 2 की power 4 and terabyte. So I told you, if you remember that 1 2 की power 10 is equal to 1k, 2 की power 20 is equal to 1m, 2 की power 30 is equal to 1g, and 2 की power 40 is equal to 1t. Right? Okay. So t will be 40. So 2 की power 40. So basically 44 will be the physical address. And please remember, here the page size is equal to frame size. So 12, it will be 12. Now 4 minus 2, 2, and 4 minus 1, 3, 32. So basically 32 bits will be used for E. So you can say 2 की power 20 multiplied by, now 32 bits is equal to 4 byte, right? So you can say 4 byte. Now the page table size will be it will be m 4 MB. Are you understanding? So my RAM, I have RAM, and one frame size of one frame is what they have given, 12, यानी कि 4 KB. So but in 4 KB you cannot have the complete page table size, that is 4 MB. See, this is your page table which is very big, and now you cannot keep this complete page table in one frame. So what you will do, you will actually divide your page table, right? And then now you will store it in the multiple pages, so that we will require one more page table about that this page number is loaded on which frame, this page is loaded on which frame number. So you will keep this record, right? Okay. So now the next is, because this page table size is so huge, 4 MB, you cannot keep it in the one frame. So what you will do, you will divide. So basically 4 MB will be divided by 4 KB. So now how many pages, like page number 0, page number 1, page number 2, page number 3, and so on. How many page number will be there, so that we can have an entry in this. So this is known as inner page table, and this is known as outer page table, right? Till here I hope there is no problem. So if you have any doubt, any problem, so please let me know. Is it clear? Please write down, everybody. Is it clear? Then we will go ahead. Now, so basically in outer page table, I am trying to find how many number of entries I will keep on. And please remember, E will be same. So if you see 4 se 4 cancel and it will be MK. So it will be 1K. Okay. So here how many entries will be there? 1K. So basically the outer page table size I am trying to find. So the outer page table size will be, outer page table size is equal to 1K, and E, basically E is always fixed 4 byte. So now outer page table will be 4 KB. Now this 4 KB you can keep it in the one frame, because now it is okay. So this is the method of, you can say, about the concept of multi-level paging, right? So now you will not divide this outer page table because it will fit into a one frame of the thing, correct? And here I have done this. So basically your LAS is equal to 32 bit, you know, and PAS is 44 bit, we have seen. So basically you have outer page table and inner page table. So this is the proper diagram of multi-level paging. So first 10 bit will be used for outer page table, next 10 bit will be used for inner page table, and 12 bit will be for your page number. How you can see it here? See 1k, basically we have 1k and 1k is equal to 2 ki power 10. So 10 will be used for this one, right? Okay. And here you have seen what is the number of entries in it. So again we are having 1k. 1k entries, so 1k will also be 2 ki power 10. That is the reason 10 bit will be used for outer page table, 10 bit for inner page table, and 12 bit for the page offset, right? So if we see the working of this, the page table having size greater than the frame size, then it is divided into several parts. The size of each part is same as fixed size, frame size, except possibly the last part. The pages of page table are then stored in different frames of main memory, and you can say to keep track of these frames we have another page table, and that is the reason we say hierarchy of page table will be created. And we will do this multi-level paging till we get the level where the entire page table can fit in a single frame. जब तक single frame में नहीं आ जाता तब तक we will keep on dividing it, correct? Yes. So if you have any doubt, please let me know. Now I have one question for you. Tell me the answer of this question. Consider a system using multi-level paging scheme. The page size is 16 KB, memory is byte addressable, and virtual address is 48 bits long. Page table entry, they have given 4 byte. Find how many level of page table required and give the divided physical, logical, and physical address space and logical addresses. So can you try this question? Try it. I will give you only just 5 minutes. They have given logical address, virtual address, and logical address both same 48 bits, and they have given the page table entry size, okay, is equal to 4 byte. Page size is 16 KB, so it will be P and D. 16 KB will be 16 KB if you write in the form of 2 ki power 4 into 2 ki power 10. So 14 will be this one, and 48 minus 14, so it will be 4, 4 minus 1 3. Okay, so this will be P and D. And now if we try to solve, or you can say we try to find the inner page table size. So the inner page table size will be n into e. Basically n is 2 की power 34 into e 4 byte. So you can say it will be 2 की power 34 plus 2 bytes. So 34, 35, 36, 36. And you can write 2 की power 36, 64 and 30 is G. 64 GB will be your page table size. So use. Okay. Now, because 64 GB cannot be kept in the 16 KB, you have to divide your page table. So now, total number of pages in inner page table is equal to 64 GB divided by 16 KB. So 16 4 just 64, and this is G and K, so it will be M, 4M. So again, now if you try to find the outer page table size, so outer page table size will be 4M multiplied by E, and E is what? 4 byte, right? So 16 MB, and again 16 MB cannot come or cannot fit into 16 KB, so again you have to divide it. So basically 16 MB will be divided into equal sized frame, that is 4 16 KB. So now if you divide, it will be 1K. So now one new table has to be created, and it is outermost page table size. Outermost page table size will be equal to 1K multiplied by E. What is the value of E? The value of E is 4 byte. So it will be 4 KB. Now 4 KB definitely can fit into the 16 KB. So how many page table will be required? 3 page table will be required. Right, everybody? Yes. If you have any doubt, please ask me. So 3. And now you can divide this physical address and logical address. And please write down this question number 2 in the comment box. And I will check it after the class. Correct? This is your homework. Please write down what will be the division of logical address space and physical address space. And now after this, I will like to tell you about New Year virtual party, which is going to be held tomorrow at 7 PM with हम होंगे कामयाब with Gradeup. Okay, so इसी के साथ क्लास को वाइंड अप करते हैं, and please be connected with the Gradeup. Okay, so if you have any doubt, please let me know. Otherwise, I will wind up the class. So bye bye, take care, and happy new year to all of you in advance. And please write down the answer in comment box after the class. Okay, वीडियो के नीचे जो कमेंट बॉक्स आता है यूट्यूब पर, you please write down the answers there.